Hello and welcome back to another tutorial. Today I will show you how you can set up QuickTime events in Unreal Engine 4. So let me show you the result that you will get when following along with this episode. By the end you'll have a third-person character running around, and if you reach a certain point in our map, a QuickTime event will fire, telling us which key to press. If we fail that, nothing happens. So that was just failure because there wasn't any input at all. Then there is also the possibility to press a incorrect key. That would also make this jump here fail. And finally, if we just go ahead and press the correct button, so in this case it's the spacebar, we'll jump and land on that side of the level. If you want to follow along, I started with a blueprint third-person template here without the starter content, so feel free to create that project and pause until it's created. Then in our content folder, let's make one folder that will contain all of the assets we create in this tutorial. So new folder, and let's call that QuickTime Events, and I will just right click it and set the color to something like bright orange, so we know that this one here is the folder to work in. First off, for every QuickTime events there are different states that an event could be in, and we want to list that using an enum. So let's create a blueprint enumeration called e_event state. Then we'll open that up and list all of the elements here. So first off, it could be the case that there isn't a QuickTime event at all, so we will just call this state none, and that would be the default. Then we could have an event that is currently pending, so waiting for input of the player. After that, it could be that we successfully completed a QuickTime event, so we would just call this one here success. And then there are two different fail states. So one could be because we didn't press the correct key, and the other one would be that just our time ran out. So we will add two new elements and call the first one failure due to time, and copy paste it for the second one, and that will be failure due to key. Alright, these are all of the states that a QuickTime event could possibly be in. Let's save and close our enumeration. And for every QuickTime event there will be a little widget on our player screen that will display both the key that you're supposed to press and your remaining time using a progress bar. For QuickTime events it's sometimes useful to place that widget at different locations. So for example, when your player is supposed to open a door, you could place the widget somewhere on the screen that would match the position of the door, just to help indicate the relation to the event and the action in the real world to the player. So we want to be able to define the position of such a widget for every single event, and we will use a structure for that. So blueprints structure, and call that s_event widget position. Let's open that up. And if you're already familiar with UMG, you know that a position is basically made up by three different variables. So the first one would be where our widget is anchored to, so we would just call that the anchor, and the type here is just called anchors. Then there is the alignment, so let's call that alignment, which basically is just a two-dimensional vector. So for the type here, let's look for vector 2D. And finally there is the offset or position, which will also be a vector 2D. Save and close that structure. Another thing that you might have noticed in the showcase is that we were transitioning to a different camera for the duration of the QuickTime event. So let's add another structure for that, blueprint structure called s_camera transition. Let's open that up. And here basically we only need two variables. So one would be the camera that we want to switch to, and the second one would be the time for transitioning onto that new camera. Alright, so let's call the first one new camera, and the type for that will be a camera actor. So camera actor, and here we will select the object reference. Then the second variable will be the transition time, so we'll just call that something like blend time and make it a float, so we have more precise control over that time than we would have using an integer, for example. Right, so let's save and close that structure too. And the last structure that we need is one that combines all of the information you need for a single QuickTime event. So let's create another structure called s_event info or data, and let's open that up. So for every QuickTime event we will have a state of that, and type for that will be e_event state. So that is why we had to create that variable before. Then every event needs to know about the key that is supposed to be pressed. So let's call that key. For that, the type will just be called a key, not the event, just a simple key here. Then I mentioned the screen position, so let's call that a screen position, and type here will be the structure we created, so s_event widget position. Of course, we also have to know about the total time that our player has to complete this event, so that will be a float called total time. And then we'll also keep track of the amount of seconds that has already passed, so the expired time, which will also be a float. These are the 5 variables that you need for every event. So let's save and close this event info. And we already talked about the widget that will display the key to press and the remaining time. So let's also create that right now. Under user interface, create a widget blueprint, which we will call w_QuickTime event, and open it up. So this one here will be a widget that will be nested inside other widgets. So in order to work with it properly, go to your settings up here and change the full screen to desired on screen, so it only occupies the space that is defined in the elements that we're using. And we don't need a canvas panel, so let's just select and remove that. Instead, we want to start with a size box and check the width and height override of that. So now we can define the total size of this widget, and I figured out that 250 pixel in width and 120 in height work pretty fine. In here we need 2 elements, so first one would be the key and then the bar. That will be aligned from top to bottom. For that you need a vertical box. Drag that onto your size box, and then we can start with the elements in here. I want to give the key a semi-transparent dark background so it's more easily readable. So we will start with another size box in that vertical box. So this one here will be used for a key. Then we will set the height override to 75 and check the minimum desired width and set that to 100. We then horizontally align that to center and vertically to the top. You see the space that it occupies. So you might be wondering why we are using the minimum desired width here instead of the width override. And that is because the text that will later be put in here can basically be any key. So for example, it could be Q, which would just be a single character, or spacebar, which are much more characters to display. And the minimum desired width here just means that if our text is much longer than the space here, it would be resized. So then our size box would be able to occupy more space in width than the 100 here. And to give that the black background, we will add a border to the size box. Then go to your brush color and make that black with an alpha of 0.5. Also, we want our elements that will be put in the border to be in the very center. So for that you have to remove the padding for content. So just type in 0 and the content alignment will be center center. After that we will grab a text element, drop that on our border, and let's call this the key text. We want to check is variable so that later we can change it based on what key should be pressed. Let's type in something like Q for the default. Then we'll expand the font and let's increase the size to something like 27, 28, just so you can read that better. And to make it stand out a little bit more, we will go to the shadow color and give that something like a mid-gray tone with an alpha of, let's say, 0.5. So that would be it for the key text. So you can show what I meant with the minimum desired width. If you typed in something like spacebar in here and hit enter, pay attention to what happens with the border. Here the size of that would be increased to match the amount of characters, which is exactly what we want. So let's reset that to Q. And then we need the time bar. So let's add a progress bar onto the vertical box and let's call it the time bar. Progress bars are variables by default, so that's good for us, don't need to check it. Then here under size, let's select fill, so it occupies the rest of the space in our widget. And then we will enter something for the padding here. So let's say for left it will be 5 pixels, and same thing for right, so 5 pixels to left and right. Maybe something like 7 to the top and 2 to the bottom. That looks fine. If you increase the percent here, currently the fill color is blue. Let's change that to white. And we want to make the background of that bar black. So under style, go to background image and then go to tint. Here let's select something like a very dark gray and let's lower the alpha to 0.6 maybe. then hit OK. So that's looking good for the design part. Let's compile, save, and let's switch over to the graph to script the functionality here. First off, every widget needs to know about the key that is used for, and variable type would just be a key. We want to tell this widget about it when we create it, so make it exposed on spawn and instance editable. Apart from that, we also need the total time for our time bar, and that will be float, also editable and exposed on spawn. The last variable that we need is the past time, and this will not be editable or exposed on spawn, but simply a private variable, so one that is only used within this widget here. We need only one function in here called update time, and let's give that an input of type float, which will be the past time. First thing would be to set our internal variable here, so past time, to the input. And then we want to update the percent of our time bar. So let's drag that in and set percent. We need to do a little bit of math now. Let's grab our past time and let's divide that by another float, and that will be the total time. The result here is the percentage of time that has passed, but we don't want our time bar to fill up when a QuickTime event is happening. Instead, we want it to start with a percent of 1 and then slowly decrease until it reaches 0. That means we have to invert this value. So let's look for float minus float. Hook up our division here for the second pin, and for the first one enter 1. So 1 minus the past time divided by total time will be your new percent. Then we can close our function and let's implement the event construct. So when this widget is created, first off get your key text and set the text to whatever key we are supposed to display, so our key variable, and there is a function to convert that to a text which is called getDisplayName. Get key display name, then you can simply hook that up. And after that we will update time with the past time being 0. Compile and save. Another feature you might have seen in the showcase at the very beginning is that based on how our player completed the event, we are playing a different animation. So either our event widget will be highlighted in a green color to show that our player succeeded, or it will light up red and then fade out to show that player missed the event or failed. For that we need animations, so let's simply grab our timeline, drag that up so we've got some space to work with, and hit the plus animation button. So let's call the first one success and double click. Then you get your timeline here where you can animate it. And what we want to achieve is that our widget fades out slowly, and during that time our key text and the time bar will light up green, and we will also slowly increase the size of that key text to make it stand out. So at time 0, 0, we will select the W QuickTime right up here in the hierarchy, then scroll down to behavior and render opacity. If you're not using the latest version of the engine, you might not have this setting, and hit the little keyframe icon. So this will be a value that will be animated. Then go to your key text and do the same thing for color, which will be animated, and scroll down to render transform and scale, and finally to the time bar and its fill, color and opacity. So these are the 4 values that will be animated. Let's move our marker here to, let's say, 0.1. And here we'll go to our key text, to the color and opacity. Let's make that very light green and hit keyframe. So that will be animated. Let's also go to color and opacity again and drag that onto our palette so we can use the same thing for the progress bar. Then select your time bar, go to fill color, select the green of our palette and also hit the keyframe button. And let's go back to the key text, to scale, and here we will enter 2 for X, 2 for Y, and also hit that keyframe button. So right now you see size of that increases and goes to green. Let's say it will stay like that for 0.25 seconds. So we'll go to 0.35 in our animation and just add another keyframe for the same scale and same color of our text and for the same color of our time bar. Then after another 0.1 second, so at 0.45, we'll say that it fades out again. So with our time bar selected, let's go to fill color and make it white. Then hit the keyframe button, go to our key text, also make that one white, hit the keyframe button, then go to scale and reset that to 1, add a keyframe. Finally, we will select our widget in the very top of the hierarchy and set the render opacity to 0, and then add a keyframe. Right, so let's play that animation. See that our key will light up green while slowly fading out, and the size of the key will increase. So that is our animation. The failure animation only differs in one point, which is the color that it will light up. So let's simply duplicate our success animation, call it failure, then double click it. And let's go to point 10 seconds, select your key text, color and opacity, and let's choose saturated red here. Drag that onto our palette, keep that color saved and hit OK. Then add a keyframe. Go to your time bar and do the same thing for fill color. Choose red, add a keyframe. Go to 0.35 to the fill color of the bar, select red again, add a keyframe, and do the same thing for the key text. And add a keyframe. So if we have a look at that animation, it's the same thing except for that the color is now red. Right, let's compile and save. Adding animations messes up with the default values of your elements. So to fix that, just close your QuickTime event, open it up again, and yeah, you see that our widget is no longer visible. So let's select the W QuickTime event and set the render opacity to 1 by default. The time bar fill color will be white by default. The key text color will also be white. And then compile, save, and close your widget. With that widget here created, we need another widget that we can put this in. So let's create a widget blueprint called w_main and open that up. In here you already got a canvas panel, and there is nothing else that we need in here because we will dynamically add the QuickTime events to this canvas panel. To be able to do that, your canvas panel has to be a variable, so check is variable, and let's just rename that to canvas. Then we'll go to the graph and let's add a function to create a QuickTime event widget. So simply call that add QuickTime widget. And this needs a couple of inputs. So first one would be the key that has to be pressed. Just call that key. Then we need the total amount of time, so a float called total time. And finally, we need the screen position, so an s_event widget position called screen position. We will also give that an output. So when we call this function, we want it to return the widget it's created. So type here will be w_QuickTime event object reference, and let's just call that widget. Then we can turn to the logic. So at the very beginning, we want to create a widget and select our w_QuickTime event as the class. Because the two variables here were exposed on spawn, you get pins for them. So it's asking you for key and time, which are some of the inputs we created, so hook them up. Then let's grab our canvas. To display our QuickTime event, we have to add it to the canvas. So look for add child to canvas, with the content being the return value here. Then you get another return value, which is the canvas panel slot object reference. Here you can set things up like the position, size, and so on. And first off, we will set auto size to true. So that way our QuickTime event will always have the size that we defined in there with the size box. After that, off of the return value, we will set anchors. And to grab these off of the screen position here, let's drag a pin and break it. Then you've got access to anchor, alignment, and position. So hook up anchor. After that, we will set alignment, which will also come from the break node. And finally, off of your canvas slot, set position and hook up the position from your break node. After all of that calls, we can go into the return node and the widget here being the return value of our create node. Compile, save, and that's already everything for the main widget. So let's close it. We also want to display this main widget. So we want to do that in our third person character. Or if you're using the first person template, would be the first person character. Just open Blueprint Editor. And first off, the jumping will be part of our QuickTime event. So let's remove the functionality here that handles jumping on spacebar. Remove that. Also no need for touch events, and gamepad can also go away, as well as VR stuff. Then right click somewhere and look for event begin play. And here we want to create a widget, which will be the main widget. Later we need to access this, so let's make it a variable. promote to variable, main widget. Then I'll get the player controller and off of it set input mode game only. We can do that because there are no widgets in this project that require inputs, like buttons for example, so we can just set input mode to game only. And after that we want to grab our main widget and add that to the viewport to display it. Alright. Now getting to the core of the system, we need a variable in our character, which will be the current event. And that is where the last structure that we created comes in place. So an s_event info. So this here will keep track of the state of the current event. If there is no QuickTime event, it would be none. Then the key that is supposed to be pressed, total time, and the amount of time that has already expired. For the keys, we can basically select anything in here. So we don't know which keys exactly will be used for QuickTime events right now. The only thing that you can do in such a case is to implement the AnyKey event. So like the name suggests, this event is simply called when any key is pressed, and here you get a variable, a key structure, which will be what key was pressed. So if we press any key, let's check whether there is a QuickTime event right now. So get current event, break it, and switch on your state. So look for switch on event state, hook that up to press, and you get execution pins for the different states of a current QuickTime event. The only thing that we want to implement here is pending. So only if we're waiting for input, we want to proceed with any logic. So if it is pending, let's add a branch. You can hold down B on your keyboard and left click to quickly add one. And let's check whether the key that we are waiting for, so off of the event info, double equals the key that was pressed here. And hook that up to branch. Then connect your branch to pending. And if that's true, the correct key was pressed. So grab your current event. And in here we want to update its state. So to do that, set members in as event info. Then right click that node and restore all structure pins. We only want to modify the state. So you can right click that and remove all other pins. So if it's true, we will set the state to success. And for false, so an incorrect key was pressed, we can copy paste and just say the state now is failure due to key. Though we implemented that functionality here, we can't really integrate the actual logic for starting QuickTime events in our player character, because that would mean that we would have to define every single QuickTime event of the entire game in this character and what happens after that, which we don't really want. We basically want every class to be able to start a QuickTime event for the player. So the solution for that is what is called a macro library. Macros are somewhat like functions. However, there you get the chance to use execution pins as inputs and outputs. Apart from that, you're able to use time delayed nodes in a macro. So things like a delay or a wait task can be performed in macros, but not in functions. And the library just means that this can be accessed from every class and not just from the one that is created in. The problem with macros, however, is that you haven't got access to variables in there and can't create any. So that is why we need that current event in our third-person character, and all of the other variables later will also be created here and just referenced by the macro. So keep that in mind. To create our macro library, just right-click in your content browser, then go to Blueprints and Blueprint Macro Library. Then you're asked to select a parent class, which would be actor in this case. So every class can reference the logic of this macro. And let's call that QTE for QuickTime event _ library and open it up. It already added one new macro for us, that's good. Let's rename that to start QuickTime event. So this here will be the whole core of the system. We need some inputs, so let's add one. And first off, by default, macros don't have execution inputs, though actually every function and macro needs one. So type here will be execution, and let's just call that start. Then I told you that the variables are put in our third person character. That means that this macro has to know about the third person character. So just call the second variable player, and the type for that would be third person character object reference. After that we need the key that is supposed to be pressed. So variable type is just a key and we will call that key. Then there is the screen position. So an s_event widget position that we will call screen position. After that we need the amount of time, so float that we will call time. And finally the last variable will be a camera transition, and the type for that will be s_camera transition. There's one variable I forgot, so let's add another input and let's call that dilation and make it a float. and move that one pin upwards. So camera transition is the last element. One thing you see very often when QuickTime events are used is slow motion, and that can be done using a dilation. So for example, if that would be 0.5, time would run half as fast as usually. Now we can turn to the outputs, and basically we want different execution pins based on whether we successfully completed the event or not. And for macros, it's always good to have another output that's just called without a time delay. So for example, let's go to the third person character, and there is a node called AI move to. If we have a look at that, we've got an on success and on fail, which are called when an AI reaches a certain point. There is another pin up here without a name that will just be called directly after this macro. So you could potentially do variable or function logic without having to wait for on success or fail. To create that one, just add another execution as output. Currently that reads new param. If you want that to be blank, just type in then and hit enter. Apart from that, we need two other execution outputs. First one being success, and second one would be failure. So failure here would combine both due to time or due to an incorrect key. To directly go into the first output here, so we can do other logic after it, let's use a sequence. And for the then 0, we'll go directly into the output. And for then 1, we can do the rest of the logic. First off, let's check whether we need to switch to a different camera. So grab your camera transition, break it. And off of the new camera, we want to check for is valid. So did we select anything in here? Hook it up to then 1. If it is valid, we need to switch the camera that is used for a game. So for that, you need to get the player controller and off of it call set view target with blend. Then hook it up to is valid. New view target is the new camera. So let's hook that up. Blend time also comes from our camera transition, and we'll make that linear. If it's not valid, we will just skip the node and proceed with the rest here. To do things like slow motion, off of your player, set custom time dilation. So hook that up to both is valid and the is not valid. And the time dilation comes from our input dilation. So that single node here handles everything for slow motion, or if you want to speed up the time of your game. Then we want to update our variable in the character that keeps track of the current event. So off of your player, set current event, and then off of the current event, we will make an event info and show all of the pins here. So the state is pending when we create a new QuickTime event. The key comes from our input, same as our screen position, as well as the total time, and the expire time will be 0. After that, we want to display the event widget. So off of your player, grab the main widget, and in there we created a function called add QuickTime event or QuickTime widget. So the key here will still be the input key, total time again from our input time, and screen position also feeds in there. That gives us a return value to the widget, and it would be good to store that in a variable so that we can access it later. However, I told you in macros that's not possible, so let's head back to the third person character and add a variable called event widget, which will be of the type w underscore QuickTime event object reference. Compile and save. Then back in our macro library, we can after this go to a player pin and set event widget. So this is the workaround for storing variables. Hook that up and connect the widget. After that, we will add another sequence. And let's move our outputs to the very right side because there is a lot of logic missing. So first off, the then 0 path here will handle waiting until our QuickTime event would be finished because of time. And if there hasn't been input until then, it would stop the QuickTime event. So what we need is a delay node. And for that, let's drag off of our player again, grab the current event, break it, and under default categories here, we want to display the total time and hook that up to the delay node. So we're waiting until the total time. And in here, let's also show the state. And after the delay, we want to switch on that, switch on eState. And if it's pending or failure due to time, we will stop the event and return with a failure output. So for our current event, let's set members, restore all structure pins, and right click the state and remove all other pins. hook that up to pending and failure due time, and we will set the state to failure due to time. Another thing that would be good to have is an event in the player when QuickTime event is done. So let's go to the third person character, and somewhere here let's add a custom event called onEventCompleted. We will give that two inputs. The first one will be the result of that event, so the state that we end up with, an e_event state. And in here we will also handle going back to the default camera. So let's give it a s_camera transition called camera transition. We won't implement that right now, but just so that we can call it, we already created it. Go back to your macro, and after we set the members, again let's drag off of the player and call onEventCompleted. Hook that up to the set members. Result would be failure due to time. And the camera transition will come from our input, camera transition. After we did all of that, we will go into the failure output of our whole macro. So that is the whole logic for when there wasn't any input of the player at all. Here the then_one path will now check whether there was input from the player, and if it was correct, go into success, if not into failure. For that we need something like a timer that checks every X amount of seconds whether there has been input or not. Problem is that you're not able to set timers in a macro, so we have to code our own timer. And timers always have an update rate or interval, and to make that a variable, let's go to our third person character, create a variable called event update rate, make that a float, and let's say we want to update or perform the check every 0.05 seconds. So that would be 20 times a second. If later you see that it doesn't run smoothly, you can always lower the value here. But keep in mind that this will affect your performance. Part and save, and back in our macro. For our then_one, we add a delay node. The time we wait will come from a player. So here let's get the update rate, event update rate, and hook that up to the duration. After that, we want to update the current event. So of the current event, set members again. Restore all structure pins. We already did that. But this time we want to update the expired time. So remove all other structure pins. We always want to add something to the expired time. So off of the current event, let's also break that down here and get the expired time. Then to this, we have to add a float, which will be the event update rate. So the time that has passed since the last update of it. And we also want to add another thing, and that will be get world delta seconds. So returns the frame delta time in seconds adjusted by time dilation. Hook that up and connect it to expired time. This updates the variable but not the time bar on our widget. So off of our player again, we'll drag and get the event widget. And then we will call update time. To grab the past time, simply go to your event info and hook up expired time. After that, we want to check whether there was an input. So let's get our state, or let's rather use our break node down here and show the state and switch on that. So if there was an input, we will either be on the success path here or on the failure due to time path. If it's still pending, there hasn't been input yet. So then we will go back into our delay node. And basically that is the way you code a manual timer without using the timer node. You simply loop back onto a delay node and then update. So for success, let's copy the onEventCompleted and paste it for success. Result would be success. And then we'll also go into the success output. The camera transition comes from our input all the way up here. And also grab the player and hook that up to the target. Then copy paste it for the failure due to key. And after that, go into failure. Result would be failure due to key. And again, camera transition would be the same here. So we'll just double click it to get a reroute node. And then we can drag off of it, go into camera transition. Do the same thing for the target, so the player, and save. Alright, so that is the whole macro. I know it's very messy because of all the wires in here, but believe me that making it a macro is extremely useful later on when you call this event, mainly because of the execution outputs. So let's revise what we're doing here. When we start a QuickTime event, we first go into the first output here, the then, that is not labeled. In case we want to perform other logics, basically at the same time while our QuickTime event takes place. Then after that, we check whether there is a new camera that we want to switch to, and if so, we will linear interpolate to that camera using the blend time and new camera. After that, we will set the dilation of our character, which could cause something like slow motion, and update the current event so that our player knows that there is a current event which is pending and waiting for a key input. Apart from that, we're adding the QuickTime widget to the main widget so that we see the key to press and the amount of seconds left, and store that in a variable within our character. Then we are basically performing two things at the same time. So the first is our little timer here. So based on the event update rate of our player, we're constantly updating the expired time of that QuickTime event and displaying that on the widget. And then if we have a look at our third person character, the event any key would set the state of our current event to success or failure due to key based on what we press. And every X amount of seconds our macro checks whether the correct key was pressed, and if so, call on event completed and go to success. And if not, go into failure due to key and into the failure output. If nothing was pressed or pending, we will go back to the delay and repeat the logic. At the same time, we're waiting for the total time of that QuickTime event, so the whole duration. And once that is completed and we're still pending, we will say that we failed the event because of the time and also go into the failure path. Alright, hopefully that's somewhat understandable. Let's close our macro library, and back in our third person character, we need to set up the on event completed. So first off, if there was slow-mo so far, we want to undo it. So set custom time dilation to 1, which is the default. Then also switch back to the camera of our third person character. So break your camera transition, get the new camera, check whether that is a valid one. If it is, so that means we switched to another camera before. And then we will get player controller and set view target with blend. New view target will just be self, and blend time comes from our camera transition. Then we will get the event widget and check whether that is still valid, because if so, we need to remove it. Hook that up to both the set view target and the is not valid. Then if it is valid, we will drag off of it and play an animation. So now we need to check whether we successfully completed this event. So off of the result, let's check whether that equals success. Then off of this, we want to select an animation. So use a select node and hook up the return value to the in animation. Then you can select two animations for success and failure. And these we want to get from the event widget. So off of it, look for success and look for failure. Then hook up success to true and failure to false. We want to wait until that animation is done, and after that remove our event widget. So for that to happen, off of your return value of the select node, get the end time, which is the length of your animation, and add a delay node. Hook it up to play animation. Then once that is completed, get the event widget and remove from parent. So destroy it. After that, we can set the event widget to null. And that's everything you need in here. Compile, save, and close our third person character. We want to set up something like a jumping area here. So let's remove these two elements. Then I'll hold down Alt and drag a copy of this and drag another copy somewhere here so we can reach that with a jump. Maybe move a little bit to the right. And then I'll just build the lightning and continue with the video when that is done. Alright, the lightning was completed. To trigger the QuickTime event when we reach this mesh here, we use a box collision or a box trigger. Drag that in here and move it in the center. Then I will scale that up until it somewhat fits the whole area. Adjust the location and scale. So something like that should work. In the showcase, you've seen that we are switching to different camera when we're in that area. So let's drag in a camera here into the level, move it up and rotate it so it faces our little area. Then I'll also move that up and rotate it to face downwards, maybe a little bit more up. So something like that should work. If we go into the camera settings, you get the aspect ratio. So currently that's set to 1.7. For QuickTime events, you're usually using a cinematic view. So that would be something like 21 divided by 9 instead of 16 divided by 9. You can just enter that there. and it will give you that black boxes at the top and bottom. Then let's select our trigger here, and we'll go into the level blueprint, right click, add event for trigger box, collision, add on actor, begin overlap. So that is when any actor overlaps this trigger box. Later we can check whether that's the player. And also select your camera actor, and with it selected in your level blueprint, create a reference to camera actor. So when something overlaps this trigger box, we want to cast it to the third person character to check whether it's our player. And if it is, simply right click. And now it comes in very handy that we made it a macro in a library, so we can just call start QuickTime event from here. Set up to this pin. The player will be our as third person character. Let's say the key should be spacebar. For screen position, we will make an event widget position. Then off of the anchors, we will also make them. And let's say we just want to align this event widget in the very center of the screen. So for the very center, for the anchors, you just type in 0.5 everywhere. And also do the same thing for alignment, because then a position of 0, 0 means it's exactly in the center of your screen. Let's say we give our player 2 seconds. And during this 2 seconds, we want slow-mo. So let's say a dilation of 0.1. Then also make a camera transition. Hook up your camera actor. And let's say it will take 0.75 seconds to blend to this camera. Then for success, we want to perform the jump. So drag off your third person character and just call jump, and hook that up to success. And once you've got that macro library, which I admit was a bit tedious to set up, it is extremely easy to start QuickTime events from any class and just define all of the values here. Further, the outputs here are extremely useful, so that we just have execution pins for success and failure. Let's compile, save, and check whether that's working. All right, I am in play mode. Let's move on to the area. Here the QuickTime event starts. I hit spacebar and we jumped and reached that area. Let's go back there again. And this time I'll just wait until the time has passed. See also that the correct animation was played, so this time it was highlighted red and we didn't jump. And this time I'll hit a wrong key, so for example F, and we also won't make the jump. Alright, that is the end of this tutorial on QuickTime events in Unreal Engine 4. Of course, there is a lot that you can refine on this system, but just to get you started, I think this tutorial should be a good baseline. I hope you liked it, and see you in the next video.